In 1943, the United States Army Air Forces were losing planes over Europe at an unsustainable rate. During specific strikes into German territory, like the raid on Schweinfurt, the Allies lost up to 16% of their entire heavy bomber force in a single day. The B-17s were called flying fortresses because of their massive arrays of heavy machine guns. American commanders believed these bombers could defend themselves during deep penetration missions without any support. They were wrong. No Allied fighter in the inventory had the internal fuel capacity to stay with the bombers all the way to Berlin and back. The moment the short-range escorts reached their fuel limit and turned for home, the bombers were left exposed. German Luftwaffe interceptors, like the Messerschmitt Bf 109, would wait for that moment to swarm the formations and pick them apart. The casualty rates were staggering. Without a fighter capable of making the full round trip, the Allied aerial campaign over Europe faced total collapse. The machine that finally addressed this crisis started as a desperate request from the British. In April 1940, facing the prospect of a German invasion, Great Britain approached North American Aviation to build standard P-40 fighters under license. Instead, the company's president, James Dutch Kindleberger, made a daring proposal. He claimed his team could design and build a completely new, superior fighter from scratch, faster than they could set up a production line for the older P-40. The British gave them a deadline of 120 days. A design team led by Edgar Schmood and Raymond Rice worked around the clock, drafting and assembling the new airframe in a frantic effort to meet the requirement. In just 102 days, the prototype was rolled out of the hangar. While it was an engineering feat, the early Mustang still lacked the specific performance profile needed to win the air war over Germany. These early models used the American Allison V1710 engine. It was fast at low altitudes, but the Allison lacked a supercharger. Above 15,000 feet, the engine could not get enough oxygen. Its performance dropped off, leaving the plane sluggish in the thin air where the bombers operated. A British test pilot named Ronald Harker noticed that the airframe handled beautifully despite the engine's limitations. He noted that the Mustang's dimensions were similar to those of the Spitfire and suggested that the British Rolls-Royce Merlin engine might be a perfect fit. In late 1942, engineers combined the American airframe with the British Merlin engine. This version of the Merlin featured a two-stage supercharger, providing the high-altitude power the Mustang had been missing. This engine swap moved the Mustang's peak performance to the thin air above 15,000 feet. The P-51 was no longer limited to low-level reconnaissance. It could now engage the Luftwaffe's best interceptors at the same altitudes as the bomber streams. The Mustang's speed was also a result of its advanced aerodynamics. On typical aircraft of the 1940s, the shape of the wing created significant air turbulence, which acted as a constant brake on the plane's forward progress. To solve this, the designers used a Laminar Flow Airfoil. By shifting the thickest part of the wing further back, the airflow remained smooth across more of the wing's surface, drastically reducing the amount of drag generated by the wings. The designers placed the radiator scoop under the plane's belly, turning drag into an advantage. This utilized the Meredith Effect. Air entering the scoop to cool the engine absorbed heat and expanded. Forced out a narrow exit flap, it created jet thrust. These two innovations meant the Mustang could maintain higher cruising speeds while using less fuel. The jet thrust from the scoop effectively offset the aerodynamic penalty of the radiator itself, making the aircraft exceptionally efficient. By late 1943, the iconic P-51D arrived in Europe. It carried one final addition that redefined the air war: aerodynamic drop tanks. These external fuel tanks were made of lightweight metal or even pressurized paper. They allowed the Mustang to carry enough fuel for the long flight into Germany and could be jettisoned the moment enemy fighters appeared. The range comparison was stark. While the Spitfire and P-47 Thunderbolt were limited to roughly 1,100 miles, the P-51D could cover over 1,600 miles. This meant the Allied bombers finally had lethal, agile protection for every single mile of their mission. The presence of the Mustang had an immediate impact on the German high command. When Luftwaffe commander Hermann Göring saw P-51s flying over Berlin, he reportedly told his officers that the war was lost. In 1944, General James Doolittle changed the strategy for the 8th Air Force. He ordered the Mustangs to stop flying in defensive circles around the bombers and instead commanded them to actively hunt the Luftwaffe. The Mustangs began aggressive sweeps miles ahead of the bomber formations. They intercepted German fighters before they could even reach the bombers, systematically destroying the veteran pilot corps of the German Air Force on the ground and in the air. This absolute air supremacy was essential for the invasion of Europe. Because the P-51 had cleared the skies of the Luftwaffe, the D-Day landings in June 1944 could proceed without the threat of a meaningful German aerial counterattack. The Mustang service extended into the Pacific and later into the Korean War. Even in the jet age, its rugged design and ability to carry heavy loads made it a reliable choice for ground attack missions and close air support. Today, a small number of these aircraft are maintained by private collectors and historical organizations, serving as flying reminders of the engineering efforts of the 1940s. The P-51 Mustang remains a testament to the speed of wartime engineering. Through a unique international collaboration, it filled a critical strategic vacuum and established the air supremacy that ultimately reshaped the map of Europe.